Good morning and welcome. Thank you for joining today's session, IAM for Enterprises, how Vanguard has matured their IAM controls to support a micro-account strategy. My name is Ilya Epstein. I'm a Principal Solutions Architect with AWS. I've been with AWS for 3.5 years, working primarily with financial services organizations like Vanguard. I'm joined by Raj Sharma, who is a Senior Application Security Architect at Vanguard. Before we get started, I just wanted to ask a few questions from the audience. How many folks here work for organizations in highly regulated industries? Awesome. How many folks here are developers or engineers? And how many are security professionals? Okay, great. And how many of you sometimes struggle to find a balance between agility, DevOps, and security? Awesome. This is the right session for you. I'm really excited about this session because when you go to AWS security talks, very often we talk about the fact that you don't need to compromise between being agile and DevOps and security. But not as often do you hear customers like Vanguard, enterprise in highly regulated industry, talk about how they're actually being able to accomplish that. And that's exactly what Raj is going to talk about today. We're going to talk about how Vanguard is enabling their developers to move fast, to be agile, but without compromising on security and making sure that developers stay within the boundaries. Now, before we get started with Vanguard's micro account strategy and how they're enabling their developers to move fast and how they're using federation and permission boundaries and organizational boundaries, I want to provide a brief overview of IAM. Just to make sure that we're familiar with the key concepts that Raj is going to talk about, especially things like permission boundaries, which is a relatively new feature but super powerful that was launched just a few months ago. I'm going to start with a basic IAM primer. This is a 300-level session, so I'm assuming most of you are familiar with IAM. Again, I just want to make sure we're all on the same page in terms of the key terminology and concepts. So what I'm going to do is I'm going to start with a typical IAM workflow and just explain some of the key components. You first start with a principal. A principal in IAM could be a user, and of course users could be put inside groups. But a principal could also be an IAM role. Unlike a user, which is typically associated with a specific person and typically has long-lived credentials like a username and password or an access key and secret key, an IAM role is something that could be assumed by a trusted entity, right? So you could use, for example, IAM roles for delegated access cross accounts, or you could use IAM roles for federated access from your identity provider, or you could also have service-linked roles, which are roles that our services use to execute certain actions on your behalf in your accounts. And then, of course, you could also have your applications, right? Your applications can be making calls to other AWS services, and that could be a principal as well, and typically would use an IAM role in that case also. Now, in order to do anything in AWS, it's an API call. So first you have a request. Now that request will contain certain things. The request contains an action, what am I trying to do? So for example, EC2 run instances, right? It will contain the resource, maybe my instance ID. It will also contain principal, who is the calling principal of that API action. Environment data could include, for example, an IP address, where is that call coming from? And some additional resource data, for example, the tag on that EC2 instance. Then IAM has to authenticate you, right? Now, depending on who you are, if you are a user, that could be long-lived credentials. It could be username and password. It could be an API access key. But if you're using an IAM role, that could be a short-lived credential that maybe is vended to you by our simple token service, STS. And of course, you could also have things like an MFA to make sure that the authentication is secure. Now, once you're authenticated, we have to determine authorization. And in order to determine authorization, IAM has to look at a bunch of different types of policies. First, we have what's called an identity-based policy. That's a policy that's actually attached to the principal. It's a policy that could be attached to a user, to a group, or to a role, and it determines what services and API actions you're able to use as a principal. The second type of policy is resource-based policy. Now, this is not to be confused with a resource-level policy. Resource-level policy is simply whether you could specify an ARN inside your policy statement. A resource-based policy is something that you attach to a resource directly. A good example would be a bucket policy or a KMS key policy. Some services within AWS support a resource-based policy. And then there are other policies that you have to look at as well. For example, the trust policy. If you're using an IAM role, who are the entities that are allowed to assume that role? So trust policies have to be evaluated also. And a permission boundary, which I'm going to talk about in a few minutes, a new type of policy that we introduced relatively recently. So IAM will look at all of these things together, and of course, if you have permissions to be able to perform that action, you'll be granted access to that resource. And of course, if you don't have permissions, you'll be denied. So now that I'm talking about the concept of roles, I just want to go through a simple workflow of how cross-account access, for example, works with STS, because Raj is going to talk a lot about how they've implemented Federation within Vanguard, so I just want to make sure we're familiar with the concepts. So let's look at a simple use case. We have two accounts. We have a dev account and a prod account. In a dev account, we have an identity, an IAM user called Alice, and perhaps Alice, for a production support issue, needs to temporarily look at some data within a DynamoDB table. And we don't want to create an identity for Alice in the production account. We just want to delegate some access to her on a temporary basis to be able to look at the DynamoDB table. So what do? The first step is, in the production account, we'll create an IAM role, let's say called DynamoDB role. And that role is going to have a trust statement to allow principals within the dev account to assume that role. That's called the trust policy. That policy, in this case, it's allowing any principal to assume that role, but you could be granular and could say only Alice is allowed to assume that role. I then have to attach a permission policy to that DynamoDB role that specifies exactly what is it that Alice will be able to do within that account. In this case, it's only read APIs to DynamoDB, and you could see we are only allowing one specific table within that resource policy, just the books table. And then, of course, the final step is, in the dev account, because Alice is now going to be doing an assume role call to STS, she needs to have permissions to assume a role within the production account. So what does the flow look like? Alice first authenticates herself with her own credentials to STS and makes an assume role call. STS gives back temporary credentials, and then Alice could use those temporary credentials to be able to access that DynamoDB table. And this is a much better model to use this delegated approach than having to create an identity for Alice within the production account. Another flow that I want to walk through, it's very typical, is AWS console access, right? That's another use case for an IAM role. And in this case, let's talk about integration with your on-prem identity provider, and let's say using SAML in this case. In this case, the first step is the user will log in to a portal to authenticate themselves against their IDP. This could be, for example, ADFS. Once the user is authenticated, they get back a SAML assertion, the SAML assertion based on the SAML claims. So, for example, for AWS console access, very often that will mean what groups am I part of, which map to IAM roles within AWS, typically a one-to-one relationship, and Raj is actually going to talk about that as well. And then you take all that SAML assertion information, you pass it into the AWS sign-in URL, and then because there is a trust relationship that's established between your identity provider and AWS console service, you're able to access the AWS console. So that's another typical flow. Now, there's many other things. We have an AWS SSO service. I'm not going to go deep into some of these other services. I just want to kind of prep you for some of the concepts that Raj is going to talk about. The next key concept I want to discuss is permission boundaries. And the idea of permission boundaries is it allows you to create delegated IAM administrators within accounts with governance and control in mind. Now, why do you need to delegate IAM controls? Why can't a centralized IAM team create all the policies? And the answer is sometimes when you use AWS services, like, for example, Lambda, if you're familiar, you have to create what's called an execution role. Right? If your Lambda function needs to access, let's say, an S3 bucket, the Lambda function needs an execution role that has permission to that S3 bucket. Having the developers wait for a centralized team to create that role, attach a policy, could really take a long time. So we want to have a concept of developers in the DevOps team to be able to create their IAM roles, but we want to do it in a safe manner. Before permission boundaries, this was challenging, right? Because you really had certain IAM actions that, we call them godlike, right? If you allow a developer to attach a role policy or put a user role policy, they could grant access to any resource in the account, and they could do anything they want in that account. So historically, what have customers done? they would have to implement a whole bunch of detective and responsive controls to be able to address that. Maybe they would have a CloudWatch events that would trigger off and see what kind of role the user created and maybe have to roll it back, but it was not really effective. And it was not really a preventive policy, right? It was really just detective and responsive. So what permission boundaries allows you to do is it allows you to delegate IAM administration to your DevOps teams, but put a boundary, a scope to what they could do. So they could create their Lambda IAM role, they could create their Lambda policies, but they could never step outside of the boundary that you have defined. And this really allows developers to move fast. They don't have to wait on that centralized team, and that's what increases the agility. So let's walk through an example, an end-to-end example with permission boundaries and how it works. And whenever you're dealing with permission boundaries, you want to look at it from two perspectives. The account admin, who in this case, assume it's a centralized IAM team, and the actual DevOps team. So let's start with the account admin. The first step is to create your permission boundary. The permission boundary uses the same IAM policy language. Anything you could do in a typical IAM policy, you could do in a permission boundary. So in this case, if you could see, we're defining certain actions that are allowed in the account, like access to S3, Lambda, DynamoDB, and so forth. But we don't want the developers to do anything with certain sensitive buckets. So we put a deny policy on the CloudTrail bucket, so the developers don't accidentally delete that bucket. And we're going to call this permission boundary as company boundary. So that's step number one. Step number two is now I'm going to create my DevOps role, and I'm going to allow the developers to create IAM policies and roles, right? So I want to give them IAM create role permissions. I want to allow them to attach the policies. But if you notice, there's a condition statement that says only if they attach the company boundary. If they don't attach that company boundary, the ability to create that policy will fail. So this becomes a really safe way to allow the developers to create these policies and these roles for, let's say, their Lambda functions, but making sure that they will never step outside of the boundary. Now, also at the bottom snippet, you will see that we're also allowing the developers to create certain policies and even delete versions of policies, but we're scoping it down to a specific prefix. One of the nice features in IAM is you could organize your policies into folders, prefixes. So for example, if the account administrators, the IAM central team has certain policies they don't want anyone to touch, they could put them in one prefix, and all of the application policies could go to a different prefix, and because we could use resource level permissions, we could restrict developers to only be able to delete or modify their policies. So I'm done with the account administrator side. Now let's look at it from the developer experience. The developer now is able to create an IAM role. So in this case, I'm creating an IAM role, but you will notice the third argument is permission boundary. And if I don't pass in that permission boundary, this API call will fail. You'll get an access denied. So you cannot evade that. Now, the developer could then create their policy, and in this case, you will see that they're actually allowing themselves access to entire S3 API, right? All the S3 resources, resource star. And I'll come back to this in a second. And then, of course, the developer then takes that policy that they have created and attaches it to their role, which then they could use with their Lambda function. So what's going to happen here? Because we have a permission boundary that says deny on the CloudTrail bucket. We have a permission that the user created for themselves, the DevOps user created that gave them access to everything, but the effective permission will be denied. If the user tries to do anything with that S3 CloudTrail bucket, they will be denied. Now, why is that? Because the way permission boundaries work is when you have permission boundaries and permission policies, the effective permission is the overlap of those two. So for example, if my permission boundary gives me access to EC2 and S3, and my permission policy gives me access to EC2 and SQS, my effective permission will only be EC2. Same thing in our use case, the effective permission will be the developer could use any S3 bucket they want, but not the CloudTrail bucket, which was denied in the permission boundary. Now, some of you may be thinking that this concept is familiar, and it is. If you are familiar with AWS Organizations allows you to create a master account, which will become your billing account. It allows you to programmatically to create organizational units, OUs, and it allows you then to create accounts, all programmatically. And what you're able to do is you're able to attach what's called service control policies on each of these levels. You could do it at the root level, you could do it at the OU level, or you could do it at the account level. And SCPs are somewhat similar to permission boundaries. SCPs allow you to control what the principals in the underlying accounts could do. So for example, you could have a whitelist of all the services that the principal could use in the accounts, or you could block certain services. You could use it in 2 modes. And the idea is those permissions could not be overridden by the local IAM administrator. So for example, I could whitelist specific AWS services, let's say EC2, S3, but not maybe, I don't know, SQS, just as an example. And then even if the IAM administrators in the local accounts give them access to SQS, they will not be able to use SQS service because in the SCP you have not whitelisted that service. And that's what we mean by SCPs are necessary but not sufficient. SCPs themselves don't grant you access. They just create a boundary, an organizational boundaries that you cannot step over. But you will always need the permissions within IAM to actually perform and use that specific service. And what's the effective permission between an SCP and the IAM permissions in the child accounts? It's the same concept. It's the overlap of the two. Only things that overlap between SCP and your permission policies within the actual child accounts is what you could do. Now, if we put this all together, if we now have our service control policies, our SCPs, which are, think of them as organizational boundaries, then we have our permission boundaries, which are principal level boundaries, and then we have our actual permission policy. The effective permission of the users will be now the intersection of all of these 3 things. So let's just look at a policy evaluation. Now that I have all these pieces in place, how is this going to work? Well, immediately we start with an implicit deny, and we look for any explicit deny. If there's no explicit deny, then we go on to the next step. We evaluate the organizational boundary, which is the SCP. If there is an allow in the organizational boundary, now I could look at the principal boundary. If there's an allow there, I could proceed to the next step. If the user, for example, is using an IAM role, then I could go ahead and evaluate my assume role permissions and make sure that the user is actually trusted to assume that role. Then I could evaluate their permissions and make sure that they're actually allowed to use the AWS resources. And only if they could do all of those things, the final decision will be a yes. If there is a no in any one of these steps, the final decision will be a no. So this is a brief primer, and will help you prepare for the next part of the presentation. And with that, I'm going to pass it on to Raj, who's going to talk about how Vanguard is using these concepts to create organizational and principal level boundaries.
Okay, good morning. Thank you, Ilya. My name is Raj Sharma. I'm a security architect at Vanguard, and we've been working with Ilya quite extensively on our IAM. And I'm going to show you a couple things, how we use these concepts in our enterprise. Just as a related note, there's actually some other breakouts here that describe permission boundaries and our account structure. So ENT 302 is going to talk about how Vanguard did our billing at scale. Net 323, this is how we used private link. And then also there's the SEC 316, which was a presentation earlier Monday, and it really talked about how IAM policies and permission boundaries are put together. So these are some related topics here. Just a little bit background about Vanguard. So Vanguard's one of the world's largest investment companies, offering a large selection of low-cost mutual funds, ETFs, advice, and related services. We began operations in 1975 and headquartered in Malvern, Pennsylvania. We have multiple lines of business. We have a retail business, which is for shareholders, and also institutional advisory services and international lines of business. So some of the goals that I want to talk to you about today is really what Ilya was mentioning around DevOps and how do we flatten speed bumps to get product to market safely and quickly. A lot of times when we're dealing with IAM and the centralized authority, these DevOps teams, they need to go and request, put a ticket in a ticketing system to gain access to a certain system. So that's the sort of traditional IAM approach, and that ticketing system is really the audit of who's doing what, where, and where they're coming from. So in the future, we really want to systematically keep users within their boundary. So we're going to use these concepts like SCPs, IAM policies, and permission boundaries to make that happen. Some of the things that I'm going to demonstrate here is an example of our custom federation using Amazon's STS, using permission boundaries on the current role to prevent boundary escape of the current role. Also using preventative IAM controls. And then I'm going to touch at the end using operating system level control. So micro account strategy and blast radius. So this is how we can help control what users can actually do and through a micro account strategy. This was actually our approach back in 2016. We took our basic data center approach and forklifted it up into the cloud. We had big, large accounts. We had many, many users in the accounts, many, many roles. And we start having so many roles in these large accounts, you're going to have to create very fine-grained access control. So things like resources and conditions within your IAM policy. And this was all controlled through a central organization, and it was actually difficult to scale up. Also, all these lines that are going back and forth, these would be things like VPC peering in between these large accounts. All that is going to get replaced with private link. So how are we doing federation? So the original approach was we have our user that needs access to something in AWS. This user would talk to the IDP service, which is actually a custom-written service that uses Amazon's STS. It authenticates the user against our corporate LDAP, Active Directory. And then we'll call the STS assume role on the Amazon sign-in service. A role is created and assigned to that user, and the user has a set of access keys as well as policies that apply to that user. They can then use that to connect to Amazon. And the way we did this was we mapped roles in Amazon to groups inside our Active Directory, and there was a one-to-one mapping of these groups. So every time we created an Amazon IAM role, we had to create the equivalent directory role on the other side. So this would be a simple example. We would have basically a user here, John Doe, has multiple roles that are assigned within the directory service. And the naming convention here that we used was we started with AWS and then the account number, and then the actual name of the role that was in the account. Our IDP service then took that information and created the ARN to do the STS assume role action. Our custom IDP also has a REST interface. So we built this out. This would be an example of the REST call you would make. You would request tokens for the DevOps role for this account of all ones. You'd get back this JSON object that would have your access key, your secret access key, and your session key, which you could use for command line. We also generated a console URL, so if you wanted to go ahead and hit the console directly, you could do that. So we had to create these roles in Active Directory, we create these roles on our directory server. So one of the issues with this approach was that as these users started using our accounts, we had to create many, many roles in these large accounts and create this fine-grained access control. It was a manual process to set up accounts as well back then. So when we set up an account, we had to create the roles, we had to create the items in the directory server, and it just took days, sometimes weeks, to have all this set up. And the federation and the entitlement granting became very complex. So how did we solve this problem? We want to actually shrink the account. So the number of people that were in the account or the number of systems in the account was limited to just that domain. And we did that through some automation. In one of the prior sessions, the SEC324 covers this, was the Vanguard Cloud Registry Service. And so this is a custom-built application. It's really an account orchestration tool. It's connected to our root OU. And then our account structure looks something like this in organizations. We have various system levels. So a developer system level, a staging level, and a production level. Underneath of those, we would have the individual line of businesses. And then under the line of businesses would be the multiple accounts. And all these accounts would be created through this automation tool. So for example, a user could go ahead to this orchestration, call a create account, and then start creating these accounts. Now, if we were in our prior model where we're actually creating roles for each one of these accounts, and then creating the corresponding LDAP roles. Every time one of these accounts was created, we had to create a whole other set of roles. That just turned into role sprawl within our directory server. So I'll show you how we address that. Ilya touched upon the SCPs. So that's actually a control that's placed at every level of the OUs, where we can control access as to what services are allowed and which services are not allowed. This is really the sledgehammer approach. So this, if you've ever used an SCP and you put a deny in that SCP, no principal in that account would have access to do those actions. So that you can set up very tight, very strong boundaries that way. Some of the benefits of these smaller accounts would be this blast radius. So we trust our developers. We want them to be able to move faster, and we want them to be able to create IAM execution roles and instance profiles. But if we put them in these larger accounts, they can start walking all over the account. So with the smaller account, the account itself is like its own firewall and can reduce that blast radius if anything does go wrong. The IAM is actually easier to do. And since we're moving away from the VPC peering, we can use things like declarative networking or private link instead of the VPC peering. And this will help us determine actually what accounts have access to what other accounts. Some of the benefits of our orchestration, this is really a self-service account creation. So as opposed to going to a central authority that creates your account for you, you can go and create one yourself. And also, because that blast radius is very small, the IAM policies no longer need to have these explicit condition statements anymore. We can actually have things like resource star in our policy, or we actually remove the condition entirely because they can only impact the things that are within that account. Okay, so how do we get from that original model of STS to the newer model? So I said the problems with some of the direct mapping, a large amount of our Active Directory roles, and the entitlement granting. So we came up with this system of indirect mapping to accounts at the OU level. And what that led to was fewer Active Directory roles and a simpler entitlement granting strategy. Folks who were administrators automatically got access to new accounts. So we're actually doing the entitlement granting at the OU. So if new accounts are created and there's an administrator, let's say a production support or an IAM administrator, they would automatically get access to that account. That leads to the scalability and also helps with the role lifecycle management. So we don't have so many roles to keep track of. Okay, so how do we update our IDP service? So this time, our user is going to go ahead and authenticate to the IDP service just like they did before. And we'll pull a list of roles by OU. We do this by using the organizations. So organizations has all our accounts set up in there. And we know which OU that they're going after. And we can pull all the accounts, the account numbers for that OU. We then call the sign-on endpoint for STS. And instead of with a single ARN, we call it with multiple ARNs. So we do multiple assume role commands. And then this leads to a set of access keys and a set of permissions that they can use. So now our LDAP role is actually mapped to an AWS OU. And this is all done through custom coding of the IDP using Amazon's STS service. So now when you look at our entitlement mapping here, you have the same user here, John Doe, but instead of the entitlements done at the account level, they're done at an OU level. And this is what the IDP uses to pull out the various account numbers. So what does this look like? If this is our account structure, or simplified account structure, and I have 3 users here. Enan is an IAM administrator, Bob is a retail DevOps user, and Alice is production support. And they are members of these corresponding groups. When we do the federation for Alice, for prod support, she gets access to all the production support. She gets access keys for all these production support accounts. Bob is a developer, so his entitlement granting is going to be done at the retail OU level for developer and has access to just those accounts in the retail environment. And Enan, who's an IAM administrator, has to manage all the accounts. We'll assign the entitlement at the root level. And then our STS service will generate keys for every single account. So we're able to accomplish blast radius because you can only federate into one account at a time. If you needed to move to another account, you actually have to log off and log back into the next account. So our IDP service now, our REST API, instead of returning just a single access key and secret keys, it returns an array of these keys. We're also able to then create common roles for each one of these accounts. Things like administrator or privileged roles. These would be like your bootstrap, network administrator, IAM admins, and then some of the non-administrator roles, like auditors, DevOps, fraud, and also some third-party monitors. So every one of these accounts, as the VCR service spins up these accounts, it automatically creates these roles with a proper trust relationship. And that's how we're able to contain the blast radius using micro accounts. But how do we keep people, once they're within the account, how do we keep them from getting outside the boundaries of the account? How do we stop a non-administrator from becoming an administrator? And that's where we use the concept of IAM boundaries. So Ilya touched upon this at the beginning. Here's sort of an example day of what one of our developers could be doing. They could create, let's say, an S3 bucket. And then they're going to create an IAM role. Then they're going to put an IAM policy on the role that has a specific S3 bucket as a resource. So the IAM policy says, I can access this S3 bucket, and that's a resource constraint. They're also going to put the corresponding bucket policy on the bucket, restricting only access to that one IAM role. So we're trying to tightly couple two things together here. And then they could deploy a Lambda or an EC2 instance with that IAM role. So what does this look like? So the DevOps user here would require full access to Lambda and EC2 to make this happen, and some limited IAM and S3 access. And what you wind up doing is you wind up binding sort of this, let's say, a Lambda function here with this execution role policy with a specified resource, and this S3 bucket policy that's also pointing back to the role ID. So it creates that tight coupling. So any other Lambda functions that are in this account are not going to be able to get into that S3 bucket. Okay. So what was the IAM permissions that allowed the DevOps role to do this? They could look something like this. So here we're allowing Lambda star. We're allowing EC2 star. And this is just for simplifying this demonstration here. We have a set of IAM policies, IAM actions that are allowed, and a set of S3 actions that are allowed. And then one thing I mentioned was we set this to resource star. This is really allowing them to access anything within that account, but since the account is so small, it's really not that big of a deal. But what you find is that there was no denies in that statement. So all the denies were implicit denies. And we sort of have this policy in place that, let's say, only the security team can manage an IAM user or an internet gateway or VPC peer or CloudTrail. But what if this DevOps user, what if this DevOps user tries to do any of these things? If they try to create an IAM user, they could be an attacker trying to masquerade as a different person. If they create an internet gateway, the attacker could cause a data breach. They could create a phishing site out of your account. If you have a VPC peer set up, they can leak data to an unsanctioned AWS account. And then lastly, CloudTrail. If the attacker can stop CloudTrail, they can start hiding their tracks. So these are things that we reserve for the security team or an administrator, and we don't want a DevOps person having the ability to do this. So how does a DevOps person do this? How do they escape this implicit deny? This happens is because they have this one permission called put role policy. And this is a first-degree escape, meaning that they're going to try to manipulate their own role to get out of this boundary. So I'm actually going to show you a demo here of how this works. Screen set up here. Okay, in my demonstrations here, I have basically two windows set up. The browser window that you see here would be your administrator user. the actual legitimate person that's supposed to be able to administer the account. There's a terminal window in here, and the terminal window represents the attacker. And in this case, the attacker's name is Alice. So what you see here is, this is the DevOps role that we saw before, and it has this policy here. And here's the window for CloudTrail, and you can see that CloudTrail is actually turned on in this account. Okay, so here's our attacker, Alice. Alice is actually a federated user in here, so we can call STS, and I can show you that is an assumed role with the DevOps role of Alice. So Alice wants to actually turn CloudTrail off. So first she's going to take a look and describe trails and gets an access denied, because this is the implicit deny. Is unable to do that. But she knows she has put role policy, so she's going to create something called an administrator access. And this is a JSON file that has all actions on all resources. And she's going to attach this to her own role. So it puts this on the DevOps role itself. And because they have put role policy, that was successful. Alice has just elevated her privilege. At this point, Alice can go ahead and do describe trails, and that function works now. She can then go ahead and try to stop the trails. And that was successful. There was no error returned. If you look at the administrator view here in the browser, we'll just refresh this. And you'll see that login was turned off. So this attack was successful. Okay, so how do we normally stop this? All right, we'll stop this through, the typical process is through an IAM enforcement. We'll add the explicit deny to the IAM role. So you'll see here that at the bottom of this deny policy set, stop logging is actually a denied action. We also don't want them doing anything else anymore to this role. So we'll add another policy on here that denies them the ability to modify or put role policy on the DevOps role. So we'll name the resource, and we'll say you cannot modify your own role. You cannot modify yourself anymore. Okay? So here again is the outcome of that. So this has been reset here. So CloudTrail login has been turned back on. You can see here in the role, we're going to go ahead and add the restricted policies. So we're going to take a look for a customer managed policy that was set up with all the restricted actions, with all the denies. And we'll attach that policy. So the administrator has added this restricted access. CloudTrail stop logging is one of the deny actions here. And then just for good measure, also deny self-role modification. And that's on the put role policy. So they're they're unable to put any other policies on this role. Okay, so here's our user again, logged back in with the DevOps role. This is Alice. Alice is going to go ahead and try to do describe trails again. And as expected, gets the access denied. So she's going to go ahead and try to add the administrator policy like she did the first time here. And this actually fails, okay? Because the put role policy is not allowed on this resource, DevOps. There's an explicit deny. So that's how we prevented our DevOps folks from elevating their own privilege or escaping their boundaries. Okay, well, what about the second degree, right? They're able to create roles for their Lambda function. And the second degree, this is, for the security folks, this is like the confused deputy problem. The DevOps person is going to create a deputy. This is the Lambda function that will do their escalation for them. So the way they'll do this is the DevOps person will create a role. They'll create a Lambda function. They'll update the code and the execution role on that Lambda, invoke the Lambda. And in this case, what the attacker is going to do is they'll actually create a new set of access keys. They're going to create a brand new user and with elevated privilege and use that as part of their attack. The code to do this isn't very much. This is all the Python code it really takes. You can see in this example, the user variable here is Eve, and the ARN here is administrator access. And what the code is doing is going to create the user, attach the policy, the administrator access to the policy, and then generate a set of access keys, and then return those access keys back to the caller. All right. So here's a quick demonstration of that. So here we've got CloudTrail turned back on. You can see in the roles, we have 6 roles in this account, in this sample account. One of them is the DevOps role. There's one IAM user here. Just for this example, this is the IAM user that's actually logged into the console. It's an administrator user just for this purpose, for this demo. And then there's the single Lambda function here as part of our IDP. All right, so Alice is going to log back in, and she's going to confirm that she is logged in. So she's logged in with the DevOps role. Remember, it has all those restrictions. You cannot modify yourself. So first thing to do is create a trust file, and this is used for role creation. If you've created an execution role, you need a trust profile. So she's going to create this role called IAM Full Access Lambda role, and that was successful. So this is just the empty role that was created. Now we're going to attach a policy to the role. And because there was no condition that stopped her from doing that, she can go ahead and create that policy, administrator policy, the same action star, resource star. And just to show you that policy, this is what it looks like. OK, and then the Lambda code is here. So this is the Lambda code. This is, you can see the user here is Eve again, which is the user that's going to get created with this policy ARN of administrator access. OK, so we'll take that piece of code and zip it up and copy it up to S3 so we can deploy it into the account. So we'll copy it up to S3. And the upload was successful, sent to the S3 bucket. And then now we'll go ahead and create the Lambda function. And we'll give it the name, create user Lambda. And we'll give it this execution role that we created earlier and the software that we just zipped up and sent up to the S3 bucket. And that was successful. So now we have a Lambda function with this highly powerful execution role attached to it. Now it's just a matter of invoking this Lambda. And the output is going to go into this out.log file. So that was successful. If we take a look at our output, we can see that an access key was returned. So 2 things happened here. Alice was actually able to elevate her privilege and create a user and a set of access keys. Now Alice can go ahead and use the command line to configure a new profile called Eve. Remember, this person Eve doesn't really exist. It was just made up now. She's going to copy the access key and set up the CLI here and the secret key. Set this up in US West 1. And JSON as an output format. So that was set up. And so now, using that profile, we can verify that profile does exist. There's the user. It's an IAM user called Eve. So Alice is going to go ahead and use this newly created user to describe trails. And now this works. And then she can go ahead and actually stop the trails. Oh, we'll get the trail status first, just to make sure that logging is still turned on. And we'll we'll stop the trail. So that was successful. That worked. Okay. And just to make sure the login was turned off, it is turned off there. Okay, so now if we take a look at our console now, we'll refresh all these pages. You can see that logging was turned off successfully. If you take a look at the IAM console, we originally have 6 users. There should be 7 now. The 7th user is now created, and that is, sorry, that's a role. The 7th role was created with an administrator policy. And here's the fictitious user, Eve, which was just created. And Eve has the administrator access policy attached to her. And then as far as the Lambda function, this was the function that actually executed the attack. So that's there now. And here's the code that was elevated to it. Okay? So how are we going to stop this? Well, in the past, there really wasn't an easy way to stop this. If you wanted to give developers the agility to create Lambda, to create execution profiles in order to build systems, this type of an attack was hard to, hard to stop. Until we had this thing called permission boundaries. So we use permission boundaries to prevent this type of attack. We're going to move the IAM deny statements that were in the IAM role. We're going to move them to the permission boundary instead. And then we're going to add a condition so that the DevOps role cannot remove the boundary that was attached to them. So they can no longer attach a policy to their role. Now we're adding another policy that says they cannot remove the boundary that was attached. Okay, so here's how the mitigation happens. So now we have a new actor here, the IAM administrator. The first thing they're going to do is they're going to set a boundary on that DevOps role. And this is represented by the letters PB, the permission boundary. So now the DevOps person is going to try to create the role. When they try to create the role, they're going to be forced to create it with a permission boundary. They'll go ahead and do the attack again, create the Lambda, update the code with the execution role, which has the permission boundary on it, invoke. They can go ahead and invoke the Lambda function. However, when they try to create the access key, it will fail. Okay, so here's the code for the permission boundaries. Permission boundaries like SCPs, you have to set up what you're allowed to do as well as what you're not allowed to do. So here in the permission boundary, we have 2 allow statements. One is allowing the S3 and EC2 star, Lambda star, as well as a set of IAM functionality. We're also allowing them to create a role, but in the create role, we have a condition that says you must create the role with the permission boundary. We also took some of the deny statements and put them into the boundary as well. So things like creating new policies or delete policies, things like that, setting default versions. But more importantly, the second statement here, which is the deny on delete permission boundary. So they cannot remove a permission boundary. One thing, as we were experimenting with this, just as we figured out, you want to avoid any kind of action overlap when it comes to the allow statements. If you have 2 allow statements, one without a condition and one with a condition, it's actually evaluated like an or statement. So we had actually put in here IAM star and what in the allow, and that actually gave them full access even though we put a condition in the second statement. So allows are always considered as an or condition. All right, so to show you what this looks like, this is the actual mitigation. So the IAM administrator is going to go ahead and set the permission boundary here. So this is new as of a few months ago. The boundary name is it's a managed policy. Call it boundaries. And we'll set the permission boundary on this role. So Now we have the restricted access. Now we've also put the permission boundary on it. So the permission boundary shows you what is allowed. So all the statements that were in the slide. And then here, the create role has the condition that you must include a permission boundary with it. All right, so Alice is going to go and try her attack again. She has the DevOps role. And now she's going to go ahead and create a role just like she did before, but this time gets an access denied, right? We had that condition, the permission boundary. She's going to goes back and remembers, aha, I remember someone said I had to add a permission boundary. So here she goes, adds the permission boundary, and that was successful. So the role was created with the boundary now. So now she's going to go ahead and put that administrator access on that role, so that's successful. And then go ahead and create the Lambda function. So it's the same piece of software that we had before with that role that was created, but this role has a boundary set on it. And this will succeed. So that's all good. Now it's time to invoke it and try to actually create this user Eve and get the elevated credentials. And this will fail. Boom, we get a function error, right? Lambda returned an error. The error is going to be sent back to the standard out, and you can see here access denied when calling create user. So this is how we're able to block the create user on that second degree or stop the confused deputy problem from happening. So permission boundaries can be very powerful in this way. All right, but what if my confused deputy is actually EC2? IAM and permission boundaries really only impact the the AWS API plane. They don't apply to things like the SSH data plane. So attackers could use this SSH vector to their advantage. You could lock down pass role, but it's really difficult to do this based on naming conventions inside of a micro account. Remember, we want to get away from centralized control over these people. So we just want to say, look, you have resource star. You can do whatever you want within this small, tiny account. And we don't want to enforce a naming convention on them. So how do you mitigate that? At least on the Linux side, we can use something like IP tables to block that. So you would set these commands up as part of your base AMI. So the hardened AMI that your developers are going to use should have this software in it, this little piece of code. And what this is saying is that the owners, the root or the Apache user would have access to the metadata service, which resides at 169.254, 169.254. Everybody else is rejected. So unless you're one of these two users, you're not going to get access to the instance profile that's attached to the EC2 instance. All right, so I'll show you how this works. I've set up two machines in this demo. One machine has that IP table set up, and the other one doesn't. So here we can see login is turned on, and I have a role set up here, a CloudTrail manager role. It just has the CloudTrail full access, and this is what we're going to use as our instance profile role. I have two computers set up here. One says secure, and one's just not secure. And they both have the same instance profile attached to them. So the first thing I'm going to do is log into the one that's not secure. And I'll try to go ahead and stop the trails. So I'll see what trails are out here. I can see that there is CloudTrail turned on, and I can go ahead and stop the trail. So I, as a user, and the EC2 user of this machine, have access to the instance profile through the metadata service. And then you can see here that login was indeed turned off. All right, so we'll turn login back on here. And then now I'll show you what it looks like when we do it with the other machine, sort of the hardened AMI. And the way we set this up for this one was using just for this example, user data. So this script will run as the machine fires up. And it's basically saying everybody's denied except root to the metadata service. So here's the machine that has those IP tables set. And when you do describe trails, you're not going to be able to get access to the metadata service, so you won't have any credentials. You don't really get an access denied, you just don't have any credentials to do any work here. Okay. All right, so that was that's how we really allow people the flexibility and the speed for developers, that they can go ahead and do whatever they want as long as we keep them in a small account and we use things like permission boundaries. So one of the takeaways here is really use permission boundaries on your federated roles. Automate the account creation and include the role creation if federating. And then also this gives DevOps teams the maximum flexibility, right? It gives them the ability to innovate. You're not saying that you have to name your machines this, you have to name your buckets that. They can do what they need to do. So the challenges that we addressed here using these IAM preventative controls is to use the policies to prevent principals from changing their own permissions, use permission boundaries to limit the privilege of new compute, and then use things like OS level controls, like IP tables, to limit any of these powerful instance profiles. Okay. And with that, I say thank you, and please submit this through.